Hi everybody, Seth Wallace here for Learning C Sharp. This is Unit 1, Module 1. It's great to have you with me. I'm quite excited about these tutorials. Throughout this entire journey you're going to be learning about the programming language called C Sharp. Now hopefully you've read the pre-reads, so you know a little bit about what we're covering today. And of course there's the exercises to do and the main blog itself. If you want to check out the main blog, it's I'll get it up on the screen now for you. The main blog is, of course, public string Seth. Put it over here for you so you can see it. There you go. publicstringseth.wordpress.com. Come along, check this one out. This is where most of the material is, and of course you'll have up here the pre-reads and the assessment. It's well worth doing the assessment because the assessment covers everything that we've learned today. So it's kind of like a learning checkpoint. So today we're covering the three basic variable types, what's known as the primitive variables. And we're also going to be looking at their properties. Now there are essentially three types of variables which are like containers or buckets that we will be using throughout the C# language. And what does a variable do? What does a container do? Well, it essentially stores information. It stores information for the program to use and manipulate. So it is literally like a container, and it stores that information in memory. So let's have a look at the first type. The first type is called an int. Int stands for integer, namely number. So let's just declare a variable and then we'll run through what I've just done. Equals 10. No, we won't call it name, we'll call it number. 10. Okay, so this is an integer. Okay, it is a number and it is the number 10. So we've declared what type it is. Integer is a type of variable. It's telling C# that this particular storage container can only accept numbers. Okay, you can't have text, you can't have true or false, you can only have numbers. And we've given it a name, it's called number. That is what's referred to throughout C#. So if I ever declare number, which I'm going to do in a minute, if I ever call number, that's where it's going to go. It's going to go, right, somebody just called number, what number have I got stored in me? 10. Okay, equal signs basically means has in it, and 10 is the digits it has. Now integers have a couple of simple rules. The first rule is they have to be whole numbers. So if I was to declare it as 10.25, it would immediately throw an error saying, hey, you can't do that, that's a separate type of variable, that's a different type of variable, and that's not a primitive variable. So we won't be covering that today, but we will look at different types of variables later because there are hundreds. But for now we're looking at primitive ones. So the number 10 has to be a whole number. The other thing is its length. It can't be a stupidly long number because again that's a different type of variable. That's called a long. So you're limited to about there. Maybe stick a few more and see if it'll handle it. Yeah, you're limited to that. Now that's quite big. I mean, it's a 32-bit signed integer. We won't go into what that means just yet, because if you're new to this entire thing, you've been thrown in at the deep end. If you've read the pre-read, your head's probably going to explode soon. But this is an integer, okay? It's a whole number. It can be a large-ish number, but there is a limit. And the third rule about integers is you can't have direct access to them through the UI. UI means user interface. So if I was to say, let's just delete this a minute. If I was to get rid of this and say I want to get the input from the user, so console.readline, it would probably go, wait a second, you're asking the user to input this one? No, you can't do that. Only the user can only input something called strings. Okay, so an integer has to be declared within the program or has to be converted. It can start life as a string, or it can start life as another type of variable that accepts strings, but it has to be converted into an integer. Okay, you cannot declare an integer from a user inputting information directly. That's sometimes very obstructive, but other times it's a safety mechanism, because what if a user was to input 67.75? Say I'm inputting that now to the computer directly, it would crash the program. So it's a safeguard. Okay, so we're gonna make the integer 150. Okay, now the thing about integers is you can do things like int number 2 equals 150. Now if you take number 1 and you add number 2, you will get number 3. Now it's going to be plain because I haven't actually declared this yet, so I'm going to put int number 3 equals 0 because we don't want it to have a value to start with. I'm going to put that on there. I put a minus in there for some random reason. Let me get rid of that. And that should all... Okay. Ah, of course, I've got this in the wrong number. So this is another thing about C#. Things have to be in the right syntax. We covered syntax in the pre-read. So number 3 equals number 1 plus number 2. That's the correct way of doing it. It's always based on the left-hand side. Okay, left-hand side to right-hand side. So if I was to put number 1 and number 2 would equal number 3, that would be illegal. You need to declare what the result is first. So integers are pretty cool because they can add stuff up, take stuff away, time stuff. You know, you can't do this with strings. Even if strings have got numbers in them, integers can be used to make complex equations, and we can prove this by basically going console.writeLine. I'll come back to what console.writeLine is in a moment, because I'm sure you're probably wondering that. Number 3, console.readline. Okay, let's run this, see what happens. And you'll notice that we get the number 300. Well, where did this come from? Pretty much, number 300 is a local variable number 3. That's what's in number 3. C# has taken the value of number 1 and taken the value of number 2 and added them together and then put them in number 3. And then we've instructed it to display number 3 on the screen. Pretty simple. But that is integers. That's how integers work. So, moving on to strings. A string is a collection of characters. Now, I said these were primitive variables. Technically, a string is not a primitive variable. A character, or char, is a primitive variable. But it's very difficult to use characters as standard variables on their own. So, C#, or I think it was before C# actually, came up with the idea of a bunch of characters spread together forms a string. So, to declare a string, it's the same as declaring an int. You go string, so this is your type, name 1 equals Joe. Okay, we can declare as many strings as we want. String name 2 equals Bob, and string name 3 equals, we'll put undecided. There's a reason for that, and I'm going to show you why in a minute, because you can overwrite the contents of a string by allowing the user to fill it. And this comes back to something that we covered in the pre-read called garbage collection. If this is suddenly filled up by the user, similar to how this is, then the garbage collection comes along and goes, well, you've just deleted what was in there, I'll get rid of that for you. Boom, gone. And you notice this little green thing over here. Well, this is basically saying this is a warning, but it's nothing major. It's basically saying, well, you've declared this variable, but you've never used it. You know, this is coming back to C#'s productivity. Okay, it's basically saying, you know, you've declared this, okay, but you've not used it. So let's declare. Let's do some experiments with this one, because this has rules again. For instance, you'll notice there's none of this near ints. This is ints are just plain numbers afterwards. This basically has these little guys around them. This is a kind of a clarifier for C# to say the string starts here, goes all the way along here, and it ends here. Nothing on this side and nothing on that side is part of the string. Everything inside here is part of the string. Okay? The other thing about strings is you can't do stupid stuff with strings. For instance, name 3 equals name 1 plus name 2. This is not going to do some magic mumbo jumbo of Joe plus Bob equals Jim. This is going to actually take Joe and put Bob right next to it. So it's basically going to go zip, and you're going to get Joe Bob. And if you want proof of that, we're just basically going to write line console dot write line name 3 console dot read line. If we do this, it'll do this pip first, but we'll ignore that. Joe Bob. So it does exactly what it says on the tin. It's taken Joe, taken Bob, and it's put them together. There's a word for this. It's called concatenation. It concatenates the two. It doesn't try and add them up like you would numbers. So C# recognizes as of a property of the variable. So this bit here is going to have a property. It knows that one of the properties of this is it can be mathematically added up. But one of the properties of the strings is it cannot be mathematically added up because it's a string. But when somebody uses this sign, they want you to concatenate it into one long word. When they use this sign with an int, they want you to add it up. This is another feature of C#. It takes the definition or the property of a string and it has things assigned to it that you take for granted most of the time, but C# knows them. So just remember with strings, you can't add them up like you would with an int, and when you use a plus sign it concatenates them. You must always use these quotation marks because you're declaring exactly where the string starts and stops. You must always say equals. Now, a couple of housekeeping rules. With strings, if they're going to be empty, do not do this. I see people do this all the time and it annoys me. You're essentially assigning that string dead space. Instead of doing that, do this. String dot empty. Get into the habit of doing that, because basically you're declaring that the string with the name 4 has an empty value. There's nothing in it. Do not assign any memory to it whatsoever. Okay? But I see a lot of people also doing this. String name 5. That's bad programming. Yeah, that is bad programming because oh, hang on, it's because it already exists. That is bad programming, okay? Not putting an equal sign is basically you're leaving C# in limbo land. It doesn't know whether this variable has an assignment or has not an assignment. For this one, you're clearly defining to C# this is a string that's empty. So it's good housekeeping. And the other thing about strings is there's things called escape characters. I'll cover this in the beginning because this is information you need to know. An escape character is this. String name 5 equals C value value. That's an escape character. You'll notice immediately that this has happened. Anything with this in, any of these, or any of these, or these, any of those will be considered a value within this clump of information here, which basically instructs C#. Hey, you know this thing here? Well, this means you need to escape from this block, this bubble inside here. So to get around that, you put this on. The @ symbol immediately tells C# anything within this bubble, anything at all, you treat as a string. Without it, C# goes, well, there's an escape character here. What do you want me to do with that? So there are instances where certain characters within this little bubble of the explanation of the quotation marks can escape, hence the word escape characters. So when you're using things like that, you just need to be a bit cautious. And of course you cannot use quotation marks within your string. So if you had a string that said Jane turned to Harry and said, Harry, you're looking rather dapper today. Thank you, thought Jane. Okay, in English, in the English language, that would be perfectly reasonable. But to C#, it's looking at this thinking, what's a Harry, what's a you, what's a looking, what's a dapper, and what's a today? I don't know what these things are. You basically said to it, there's the first string, bubble. I've come out of it now. these are C sharp here. This is the C sharp language, and I've gone back into the string again, and I haven't told you that it's separated or anything like that. So C sharp's basically going to look at this and go, what on earth are you talking about? I don't have a Harry, you looking dapper today. So you obviously, that rules that out. The other thing, unfortunately, it rules out is these. If you do need to do that for some reason, any reason, you decide to write a story within C sharp, do this. Jane said to Harry, "My word, you're looking dapper today." The single quotation marks are okay. Weirdly enough though, it knows the difference. If you use a single quotation mark instead of a double quotation mark, it will go, what are you doing? That's not right. You must use them. Okay, so that's strings. I'm running out of time here a little bit, so I'm going to move on to bool. A bool is a yes or a no. Okay? Yes or a no. 1 or 0, on or off. Now, how a bool is formulated is you're still declaring it. You're saying signal, signal, equals true. Or bool off signal, my spelling is awful, equals false. Okay. You'll notice two things here. Firstly, true and false do not have quotation marks around them because they're not strings. This is telling C sharp this is an on, and this is telling C sharp this is an off. So what it's basically put in this little container of information is that's on, and this one is off. Now you can only change these to one of the two. For instance, if I then said bool, if I then said signal equals James, it would go, what are you doing? James is not an on or an off, so it has to be either true or false. Now you can change the two over anytime you like. So ignoring the fact that we're going to be using an if statement here, because we'll cover statements later, what you can use a bool for is this. If signal equals true, console dot write line, signal is on. Else if signal equals false, what am I doing here? Console dot write line, signal is off. See, this is my bad programming. Signal. See what happens when I didn't include the quotation marks? It went off on a complete tangent, writing all sorts of rubbish. This is what happens when you don't concentrate when you're programming. Okay, so ignoring this if statement, because we will cover these later, I'm basically saying here, if the signal's true, then you print out this text. If it's false, you print out this text. Now the rules around booleans. Console dot read line. Just put a break there so we can see what we've done. The rule about bools, okay? Just like the ints, you cannot have direct contact with the UI. You can say, for instance, if name5 equals hello world, then this is true. If it equals undecided, then it's false. You cannot have direct access with the user. We'll see about bools, we'll cover bools in more detail later, but just know for now that a bool is an on and an off, and it's an illegal character to have anything but true or false assigned to a bool variable. The other thing you'll notice is you don't have to declare the type every time. This is the primary declaration. You are creating the variable here. Here, you're assigning the variable. So you can assign the variable as many times as you want. You can say signal true, signal equals true, and you can go signal equals false. If C# had a personality, it would be saying to me, what on earth are you doing right now? But Nevertheless, this is not illegal. You can say this, you can assign these as many times as you want. And this goes back to the garbage collection. From this point here to this point here, this point here to this point here, C# goes, alright, you've changed that, let's dispose of the old stuff and put the new stuff in. Okay? But you can only declare it once. So you can only create it once. If I try and go bool signal equals true, it's going to go, that already exists. What are you doing? That already exists. You're declaring something with the same name. So you can only create something once, but you can assign it as many times as you want. This rule applies to every type of variable. For instance, ints. You only need to put int once. After that point, if you want to declare number 3, you can say number 3 how can I put it all together, equals 1, number 3 equals 5, etc, etc. Hope if I use the right syntax. It doesn't matter. Okay, so this is unit 1, this is module 1, and this is primitive variables and their properties. I'm just going to run this now so we can see what we've done. So this is the first bit. We're asking it, can you print out number 300? Yes. Can you print out and concatenate Joe and Bob? This is down here. Okay, yes, it's fine. And through all the declarations I've done of signal, I've gone signal's false, signal's true, signal's false. So it's gone down here and it's gone, is signal true? No. Okay. Is signal false? Yes it is. Okay. Then signal's off. If I was to change this now, and get rid of this one, even though I've declared it as false primarily, I've overwritten that with signal is now true. Garbage collectors have come, they've taken the variables away, and it's gone, is signal true? Yes it is. Okay, then print this out. Signal is on. So I hope you enjoyed your first tutorial. This has been Unit 1, Module 1 of Learning C# with Seth Wallace. Join me for Unit 2, which will be up in a couple of weeks' time. Try the exercises on the blog. If you need a reminder of what blog is, it is I'm just going to get it up for you actually. If you need any help, it is publicseth.wordpress.com. Okay, and module 2 is right here. Thank you for watching. See you in the next module.